So let's say I want to find the integral of the same function from 0 to 2. So we see how we can do that earlier. I can just use the antiderivative, plug it in, and do the subtract. However, mathematically speaking, there are more common ways to do that. So let me kind of do that now. So this is going to equal to, what is the integral of 2x minus 4? The integral of 2x minus 4 is going to be x squared minus 4x. Usually we will have the plus the constant. But we see earlier that when we do the definite integral, when it goes from a number to a number, the constant always get cancelled out. So what I'm going to do here is I'm going to leave the plus c out of the equation because it gets cancelled out anyway. And I'm also going to write this notation. So the vertical bar 0 and 2, this is basically, remind myself that I'm not done yet. This is not the answer, but I have to plug in 2 and 0 to the function. So I need to plug in 2 and 0 into this function and subtract them. And that would finish my integral. So let's actually do that. I plug 2 in, I'm going to get 2 squared minus 4 times 2 minus, I plug 0 in, I get 0 squared minus 4 times 0. Wait, I mean 0. So the vertical bar that we see here is just a way of saying that this is not the answer yet. I have to plug in 0 and 2 and subtract them. And that's going to be the answer. So that's what I did here. I plug in x equal to 2, that gives me this guy. I plug in x equal to 0, and that gives me this guy. And let me actually simplify this up. So that's going to be, let me see, 4 minus 8, so that's negative 4 minus 0. So that's it. So that's my integral for this guy. Now to recap, generally, if you want to find the integral of f of x from a to b, the steps are basically this. I need to find the antiderivative. And in this case, it's actually okay to do the antiderivative without the c. And second thing, let's say your antiderivative is the big F function. When you have the antiderivative, you actually change the integral sign of a to b into the vertical sign of a to b, kind of like what we did here. Right. So when you do the antiderivative, you change from the integral from a to b to the vertical sign from a to b. And then after that, you plug B in, plug A in, and then you subtract the difference of the two. So these are basically the steps that we can use to find the definite integral of a function. So once we see that, let's actually go ahead and do the next one real quick. So this is again the integral of the same function, and it goes from 0 to 5. So let me do it quickly here. So the integral of antiderivative, this guy is going to be x squared minus 4x. So I'm done with step 1 now. To begin with step 2, I replace the integral from 0 to 5 to the vertical bar from 0 to 5. Now, so that's basically the end of my step 2. For step 3, I plug b in, which is 5. So that's going to be 5 squared minus 4 times 5. And then I plug a in, which is going to be 0 squared minus 4 times 0, and subtract the difference. Make sure it goes in the right order. By the way, when it goes from 0 to 5, that means you plug 5 in and subtract by when you plug 0 in. So that's how it goes. And then, let me see, I'm just going to compute this guy. 5 squared minus 20, so that's going to be 5 minus 0. That gives me a 5. So apparently, this is the same as this is my final answer. For the next one, I like to find the area between the graph of 2x minus 4 and the x-axis on 0 to 5. This should be rather straightforward. We already have seen the graph of 2x minus 4. So this is 2 units. Let me see, from 0 to 5. I'm not sure. You have to ask your friend somewhere. From 0 to 2, we see that this is just a triangle. The base is 2, the height is 4. And from 2 to 5, we also have a triangle. The base is 3, the height is 6. So you can compute the area of the two pieces here. The area of this triangle is going to be half of 3 times 6, so that's going to be 9. The area of this triangle is going to be half of 4 times 2, so that's going to be 4. So I'm looking for the area, and by area, I want the whole thing to be positive. So the area of this guy is going to be 4 plus 9, which is 30. The next example asks for the exact same thing, except that instead of finding area, the question asks me to find the side area. What is the side area again? The side area is similar to area, except that I'm going to consider the region under the x-axis to have a negative area. So that this little piece, this little piece 4, this is under the x-axis, so I'm going to see this as having a negative area. So this 4, this is going to be negative 4 plus 9, and that's going to give me 5. That's going to give me 5. So let's see how this corresponds to my answer earlier. When I compute the area from 0 to 2, I get negative 4. So that negative 4 is the same as that little negative 4 that I have there. So that's my integral from 0 to 2. That's negative 4. That's the sine area. So that's why it's being negative. Now then, when I compute the integral from 0 to 5, I get 5. And that's the same as the sine area that I see in the other one. So that's why I get the sine area to be 5 there. So the integral that I have computed negative 4 and 5, it corresponds to the sine area here from 0 to 2 and the whole thing from 0 to 5. Now, when we compute the area, the actual number came out a little differently, and that's because I consider the smaller triangle, the one with area 4, as having a positive area. So that's why I actually do 9 plus 4 and get 13 instead of 9 minus 4. So that's the difference between the area and the sine area.